I'm Satsuki. Today I'm going to talk about localization. Localization is important. Think about a time when you had to use a language that was not your native one. It likely took more time to understand, and it probably made you feel a little unsure or uncomfortable. Ideally, we want to build a world where everyone can have a more comfortable experience, regardless of where they were born or what language they speak. Localization is a key part of that work. Apple has also been emphasizing the importance of localization for years. At WWDC, Apple used the phrase, "feel at home," to describe it. It reflects a simple idea. Every user should feel like the experience was made for them wherever they are. However, good localization that creates a feel-at-home experience goes beyond translation. What does that mean? Let's look at a few examples. First, since we're here in Tokyo, let's look at a Japanese UI. This widget shows a delivery date. And then, here's an English UI for the US region. This one shows an inbox count. As you can see, these interfaces include localization mistakes. In the Japanese example, the order of the date does not match common Japanese conventions. In the US example, the thousand separator is shown as a period instead of comma. That period style is common in German. These mistakes look small when you look at a whole app, but they immediately make the experience feel slightly off. They're like a pebble in your shoe. It's small, but you keep noticing it. And over time, that kind of friction makes an experience much harder to love. And sometimes, the problem is not only friction. If something is localized incorrectly, it may be misunderstood. For example, this date here, is it April or November? And this number, is it 3,000 or just 3? Even small differences like these can completely change how the information is understood. We need to pay more attention to our app's localization. In this session, we want to try to cover everything about localization, and we want to dive into API implementation details. Instead, we'll explore a wide range of localization examples, so by the end, you have developed an eye for localization. So with that, let's take a deeper look at localization on Apple platforms. Much of the localization behavior on Apple platforms is driven by foundation.locale. A locale is a structure that encapsulates information about linguistic, cultural, and technological conventions. APIs use that value to decide their localization behavior. Locale is mainly defined by language and region. The system that receives a locale uses it to choose the words they display and to determine how values are formatted. In most cases, they use the default values associated with that locale, but some of those values can be overridden by the user or by the app. To understand where these behaviors come from, we need to look at the underlying data sources. Behind Foundation, ICU serves as the engine, and it works with resources like BCP47 and CLDR. Let's take a closer look at each of them. Local identifiers are based on BCP47 language tags. These tags provide a standardized way to represent language, region, and other local information such as script, so systems can interpret and match local identifiers consistently. Much of the data and rules behind locale-specific behavior come from CLDR, the Unicode Common Local Data Repository. CLDR contains a large collection of local data, such as language-specific word lists, formatting conventions, and collation rules for string comparison. ICU, which stands for International Components for Unicode, is a library that Foundation uses to implement many localization-related modules. It's a set of libraries that provides localization support for software. Using the locale identifier and the CLDR data, ICU determines the locale-specific behavior. So far, we've looked at the structure of locale and at the data sources that determine locale-specific behavior. Now, we're ready to explore where localization appears in Apple platform apps and sharpen your eye for localization. Let's start with the areas where FormatStyle is available. FormatStyle is a convenient Foundation API for formatting values while following the conventions of the user's locale. For dates, Apple provides similar FormatStyle types for presenting absolute date, relative date, date intervals, and component-based intervals. By using them, things like date order and wording are automatically adjusted for the current locale. Apple also provides FormatStyle for numbers, currencies, and percentages. These automatically adapt details such as separators and a numbering system to the locale. Percentage formatting, in particular, may look simple at a first glance, but in practice, it involves more localization details than you might expect, including symbol position and spacing. Next, let's look at a FormatStyle for values with units. Measurement.FormatStyle is used to convert values with units such as temperature, length, or area into localized string. There's also FormatStyle for list. List FormatStyle formats a collection using locale-appropriate separators and conjunctions. And finally, there's a FormatStyle for personal names. With person name components.FormatStyle, the system can choose an appropriate order for a given and family name and account for locale-specific conventions such as salutation and honorifics. So these are the areas covered by FormatStyles. FormatStyle is one of the great improvements in Foundation. In practice, developers often use FormatStyle simply to format values for display, and in doing so, many important localization details are handled automatically. That means localization can also become easier to overlook, especially outside FormatStyle. So let's look beyond FormatStyles. Let's start with calendar-related localization. Users may be using a different calendar system, such as Gregorian, Japanese, or Buddhist. This can affect both date presentation and date calculations. The first day of the week varies by locale. In some regions, the week begins on Sunday. In others, they begin on Monday. In a few regions, they may even begin on other days. And this can also be customized by the user. So if your UI shows the days in calendar order, it's worth taking this difference into account. Next, let's look at the time zones. Most of you are already familiar with the time zone differences across regions, but date and times are not always best shown in the user's time zone. For example, at the event, when you display the time of an event, showing the local time at the event location may be clearer than converting it into the user's current time zone. It's important to choose the right time zone based on the context. Next, let's look at a text. String comparison behavior can differ across locales. For example, in French, users expect these two cafe strings to be treated as a match in search. By using the localized standard range API, you can perform string matching in a way that aligns with those expectations. It supports more natural style of text matching by taking linguistic similarity into account. Sorting behavior also differs by locale. To get a natural sort order that matches the current locale, you can use sorted using the localized standard. Grammar is another area to watch. Some languages have grammar rules that may not exist in your own language. Pluralization is one example. In English, the wording changes between singular and plural, and in some languages, the rules are even more complex. String catalog can handle those variations with using vary by plural. Another example is grammatical gender. In those languages, related words may need to change form depending on grammatical gender. Apple provides automatic grammar agreement, but its language support is still limited, and the documentation is not always as complete as you might want, so it's important to evaluate it carefully before adopting it in production. In any case, it's important to remember that concatenating strings can produce grammatical unnatural results in some languages. Next, let's talk about language selection. In some languages, text flows from right to left, which is called RTL. UI layout follows that language selection. If you use standard UI components, the system will handle many of those adjustments automatically. But at a final level, there are still details to watch for. You may come across pairs of properties or SF symbols that look almost the same, such as left and leading or right and forward. But in RTL environment, that changes. Right always means the physical right side, while forward follows the language selection and flips in RTL. The same applies to pairs like left and leading, as well as similar directional terms. By understanding this distinction and choosing the appropriate property for the context, you can create layers that still feel natural across different language selections. Finally, let's talk about visual semantics. We also need to think about how meaning is conveyed visually. One example is symbols. Language selection and writing systems may also need to be reflected in the elements used within images and icons. As we saw in the previous examples, SF symbols already provide many symbols designed with these kind of localization considerations in mind, so using them can help. We also need to pay attention to color. The meaning of color can vary across regions, so any part of your app that uses color to convey meaning should be reviewed carefully. Those are the major areas of app localization on Apple platforms. Here's a summary of the areas we've covered. Okay, finally, let's look at the next actions you can take right after this session to improve your app's localization quality. Step 1, explore the FormatStyle APIs and look for places in your project where they can be applied. Using them appropriately can also help improve the overall health of your code. Use SF symbols whenever possible. Many of them are already designed with localization in mind. Step 2, start by reviewing your localized strings. For strings include variables, make sure that grammar still works naturally. At the same time, if numbers are hard-coded in strings, consider extracting them into variables so that system can automatically apply the appropriate numbering system for the user's locale. Also, try running your app with different calendars and time zones. Pay close attention to any parts that involve date handling. And also test your app in environment with different language directions and check for any layout issues. If you need an RTL environment, Arabic is one option. Step 3, take a look at the libraries and the data that Foundation depends on, such as ICU and CLDR. By exploring these underlying implementation and data set, you may discover localization points beyond what is covered by Apple's API. Stay curious about other cultures. Localization is not just about applying rules or using the right data source. It also requires us to question the cultural assumptions behind our apps. However, the most important thing is to listen to your users. We've explored the technologies behind the localization, but underneath all of that is culture. It's not something that can be fully addressed with code and data alone. So that's why feedback from users across different cultures is essential. It's one of the most effective ways to create an experience that truly feels at home. So let's remove those pebbles from our apps. Thank you for listening.